Welcome to today's webinar. This is our fourth and final part of the AHA Cardiogenic Shock Registry Research Series, and we thank you for joining us. My name is Melissa Clark. I'm the Research Program Manager for the Cardiogenic Shock Registry. Before we get started, I'd like to go over a few items so you know how to participate in today's event. Although there are no CEs available for this webinar, all attendees of the live event will receive a certificate of attendance along with the recording within 2 hours of the conclusion of the event via email. The presentation is also available as a handout, which you can download via the handout pane of the control panel. You'll have the opportunity to submit text questions by typing them into the questions pane of the control panel. You may send your questions in at any time during the presentation. We'll collect these and address them during the Q&A session at the end of today's presentation. If you experience any technical difficulties during the presentation, most can be resolved by refreshing your browser. If your issue is not resolved by following the refresh, please log off and try to enter again using Chrome as your browser. You may also refer to the GoToWebinar customer service team, whose contact information can be found in your webinar confirmation email. Our panelist today is Dr. Sunil Rao. He serves as a member of our CAD Systems of Care Advisory Group. He is a professor of medicine at NYU Grossman School of Medicine and director of interventional cardiology at NYU Langone. He was chair of the writing committee that led the 2025 ACS guideline effort, and he has multiple prospective clinical trials and authored over 300 publications in the field. At this time, I'd like to welcome Dr. Rao to begin today's presentation. Thank you for being with us.
Great, thanks so much, Melissa, and thanks everyone for joining. What I'm going to do over the next few minutes is to talk a little bit about what constitutes good research and on the clinical side of things, and kind of how to actually structure abstracts and proposals and papers in such a way that they have a good chance of being accepted and being disseminated to the reading public. I don't have any disclosures related to this talk except that I am the editor-in-chief of one of the American Heart Association journals, Circulation Cardiovascular Interventions. I've been the editor-in-chief of that journal since 2018. So, what's important about AHA registries is that they provide a great snapshot of what your practice is against a benchmark of what high quality guidelines-driven practice is. So you can identify areas in which you are leading and areas in which there are opportunities for improvement. And there are several registries that are available. I'm sure many of you are participating in these registries, but they really span the clinical spectrum from coronary artery disease to heart failure to even higher risk presentations like those who have cardiac arrest, those who have stroke, as well as those who have atrial fibrillation. I'm involved very, very closely with the American Heart Association shock registry. This is for patients with cardiogenic shock, which has been really a very, very successful registry to try and get a handle on this very high risk and high morbidity and mortality condition. Advance the slides here. There might be a little bit of a delay. All right. So what the topic is today is, what are journals looking for? So you have an idea for research. Maybe you even get a proposal that's approved. You've gotten the data. You've written something up. How do you get that published into the scientific literature? And how do you increase your chances of having a scientific paper accepted? Because I think we're all really, really interested in dissemination of the work that we're doing. So over the next few minutes, what I'm going to go over is our metrics for cardiovascular interventions. Circulation Cardiovascular Interventions is the flagship interventional cardiology journal for the American Heart Association. I'll give you a sense for kind of what drives journals. We have our own metrics that we're interested in, and we certainly want to be leading the field. We'll transition from there into what defines impactful research, and importantly, what defines well-written papers. As language evolves, as our way of consuming information evolves, what is a lost art is, how do you write well? And I think it's important that there are some fundamental characteristics that we as editors look for when we're first looking at a paper that's submitted. And then I'm going to wrap up looking maybe a little bit more towards the future. and really what is the role that artificial intelligence is playing and large language models are playing in the scientific publishing sphere, and what does that mean for the future of scientific publication? So let me start a little bit by telling you about Circulation Cardiovascular Interventions. Circulation Cardiovascular Interventions is a subspecialty journal of Circulation. Circulation is the flagship cardiology journal for the American Heart Association. There are several subspecialty journals that span different subspecialties within cardiology. So obviously we are focused on interventional cardiology or catheter-based approaches for heart disease. There's circulation electrophysiology, which is focused on electrophysiological issues like AFib and pacemakers and so forth, ablations. There's Circ Outcomes, which is eventually going to change its name to Population Health. And there's Circ Heart Failure. So there really is a variety of different venues that you can publish and submit your papers to within the circulation family. And I think you should keep that in mind. I mean, one of the things that we are challenged with at subspecialty journals is that we often get paper submissions that are simply not in our topic area. So if I get, for example, a genetics paper at Circ Interventions, that's really not something that our readership is looking for. So those papers will oftentimes get rejected. And we do try to do a good job of telling the authors, look, it's not anything that's wrong with your science, it's just the wrong journal. So that's something to keep in mind. So let me go over some of the metrics that we have here. We get about 1,200 submissions a year. And what's shown for you here is in blue are original articles. So these are original research papers. And then everything in orange is things like editorials, invited reviews, contemporary reviews in cardiology, case reports, etc. I can tell you that with all honesty, I read every single submission to Circulation Cardiovascular Interventions, from the first page to the last page. And the reason I do that is because I think that it's important when authors or author groups have put the work in to write a paper and go through the effort of submitting it to a journal, I owe it to them to at least read the paper. Now, again, that paper may not be right for us, but I do think that it's important for editors to read every single submission so that, again, the efforts of the authors are not wasted before we make any decisions. What's been really interesting is to look at the landscape of where we get our papers from. The United States is still the major source of our submissions for cardiovascular interventions. But what's happened over the last few years is that we've seen a huge surge in scientific output from China. This was particularly true during the pandemic, and it's continued even after the pandemic. And then Europe and the rest of Southeast Asia kind of make up the balance. So right now, what's happening is almost an arms race between the United States and China with respect to the scientific output. And we're seeing a lot more from China. What's really interesting about that is that, you know, just given the population of China, they're able to put together very, very large sample sizes when they're studying things like interventional cardiology. And so even a single hospital or two hospitals will oftentimes have a sample size that is multiple times what a single hospital in the United States can produce. So this is something that we are keeping an eye on. I think it is interesting to see the changes in the scientific output. The other thing, of course, that we're witnessing in the United States is that there has been a change in the way we deliver healthcare. There's a lot of consolidation. Healthcare systems are now huge corporations. There's some of us who have noticed that there may be a little less emphasis on scientific output, a little bit more emphasis on clinical output. So this proportion of scientific output may change over time, where the United States no longer becomes a leader in science. And so I think we just have to be really, really cautious about the direction that we're headed. The acceptance rate for our journal is 9.7%. So it is very difficult to get published in Circulation Cardiovascular Interventions. The process is that we get a paper that's submitted, it goes through a series of quality checks by our staff, and then it ends up in my queue. I then read the entire paper, I make a determination whether or not it's right for our journal. Oftentimes I will get consultation from our associate editors to see if it's something that we should be interested in. If the answer is no, then we try to render a decision very, very quickly so that the authors can submit somewhere else. We don't want to waste their time. And then if it is something that we would consider, we send it out then for peer review. We require at least 2 peer reviewers for every paper. That's not including a statistical reviewer. So we get a set of clinical reviews first. If both reviews are concordant and the consensus on peer review is that the paper should not be accepted, we render a reject decision. If there's any discrepancy between the reviewers or a discrepancy between the reviewer opinion and the opinion of the associate editor who's handling that paper, we discuss that as a group. We have 8 associate editors and 5 assistant editors. These are early career interventional cardiologists who've expressed an interest in scientific publication. It's a competitive process to be selected as an assistant editor. And we discuss these papers as a group and we come to a consensus about whether we should move forward with the paper or give the authors a chance to submit somewhere else. Every paper undergoes a statistical review. And then once all of those reviews are addressed and the paper is revised, we will accept that paper, and we work very hard to make sure that our time from submission to publication is as short as possible. We know that it can be very frustrating for authors who are waiting for months and months and months to hear about the journal decision. Our metrics are reasonable. I think our average time is well within 3 months, which is pretty good for our peer, compared with our peers. But we try very, very hard to make sure that those times are as expeditious as possible. Now I want to talk about something called the impact factor, and many of you have probably heard of what the impact factor is. The highest impact factors are the journals that you're aware of: Nature, Science, New England Journal of Medicine, Lancet, JAMA. And this is something that we look at, not necessarily because it's something that drives us, but it is a way for us to know who's looking at our science. Is the science that we're publishing impactful? Are people interested in it? Because that's another aspect of science, is we want to study things that are important to our readership. There's a lot of ways, like any other metrics, to game this, and there certainly have been journals who have gamed this in the past. Clarivate is the company that kind of looks after the impact factor for the journals, and Clarivate has put certain journals on notice if they've noticed that they are starting to game this. And the way the impact factor is calculated, it basically is an equation that looks at how many papers in a journal were cited in other papers published in the 2 years prior, divided by the total number of papers that are available to be cited. Again, one way we think about whether or not people are reading the papers that we publish is, are they citing it in their own research? Do they think that it's important enough to be cited? Now, what's interesting here is this denominator. What kinds of papers are eligible to be cited? Well, it turns out that basically everything is eligible to be cited except for research letters. So research letters or brief reports, for example, don't end up in the denominator, but they can be cited, of course, so they can end up in the numerator. So those of you who've been paying attention to the scientific publishing world may have noticed that over the last few years, many journals have started accepting so-called brief reports or research letters. These are usually less than 1,000 words, one table or one figure. And some research is actually ideally suited to that. It's a very focused message. You don't need a lot of fluff. You don't need a lot of figures. It's a singular message that can be put into a research letter. And the reason that a lot of journals have decided to start publishing these is that they are citable. In other words, they can end up in the numerator, but they don't calculate in the denominator. So for journals, it's very, very beneficial. It can increase your impact factor the more research letters you have. So that's why you're seeing a lot of that. Now, we, again, at Circulation Cardiovascular Interventions, take our direction from the editor-in-chief of Circulation, is Joe Hill. And Joe has said, we do not pay attention to impact factor, we pay attention to impact. In other words, the focus should be on the quality of the science. And the formatting of that paper should be relevant to what the overall scientific message is. If we feel that someone has submitted a research letter to us, but we think that the message needs to be expanded, we'll say, look, resubmit this as a full paper, not a research letter, and vice versa. If someone submits a full paper to us and we say, the message here is very, very simple, submit it to us as a research letter, that's a decision that we'll give. But it's important for people to know how the impact factor is calculated. And there are things that you can do to put things into the numerator, not the denominator, to just try and game the impact factor, and some journals have been guilty of that in the past. All right, so now let's move on to what we are looking for. And I put the 2 bullet points here. I think all journals are looking for research that's impactful, and they're looking for well-written papers. So what is research that's impactful? Well, I think certainly we can all agree that research that changes practice, and here I'm just talking specifically about clinical research. There's an entire body of basic science research, translational research that may have different goals. For example, basic science is really about kind of describing natural processes and discovering how the body works or how cells work. That may not necessarily change practice, right? But in the clinical side of things, we're looking for research that asks people to think about their own practice and whether or not the data being presented will change it. And then we're also looking again for papers that are going to be cited often, because we want people to publish in Circ Interventions so that their paper can get disseminated. And then we're looking for well-written papers. What do we mean by that? No typographical errors, correct English syntax and grammar, and things that are concise. You would be amazed at how some papers are submitted to us with numerous spelling errors, or people submit to us a paper that actually still has the track changes in it as their first submission. And so it's important. The details are important, and I'll go through what some of those details are so that you have a sense for what a well-written paper really looks like. When we think about what's important, ultimately we want to change patient outcomes. We want to improve patient outcomes. The way that information flows from the research laboratory or the clinical research centers to the patients is that there's a distilling down. In other words, there's so much science going on. Some of it influences clinical practice, even less impacts health policy, and ultimately even less gets to the bedside. So what we want to do, I think, at all the journals is to figure out what the best science is so that the vast majority of it can inform policy and change patient care. So at Circ Interventions, what we try to do is to say, who's our audience? Well, I think our audience are physicians, APPs, nursing staff, who are all at the bedside. We also realize that there are patients who are interested in the latest data. So we want to make sure that we publish papers that are impactful for patients. And then ultimately policymakers may also find some of the data that we're publishing interesting, particularly as it relates to position statements or cost effectiveness, because that may influence reimbursement decisions or billing decisions at the federal level. So, our goal is to publish not only original science, but guidelines and position statements, review articles. We are very, very interested in engaging with fellows and patients, decision tools, lectures that can be turned into manuscripts. And of course, certainly we are really, really interested in technique, because it is an interventional cardiology journal after all, and technique is a large part of what we do on a day-to-day basis. The problem is this sort of huge mountain of just awful science that we're kind of dealing with. This has really accelerated over the last few years. We're just getting inundated with a bunch of papers that really have terrible science. And it's very clear that it's a fishing expedition with absolutely no hypothesis. So, it's driven by easy access to data. There are administrative data sets that are very, very easily accessed. Some of them you have to pay a licensing fee for, others are available for free. And oftentimes it's used as a platform for people to pad their CVs, whether it's to get a promotion or to apply for fellowship. Oftentimes there's no hypothesis. They have no idea what they're really testing. They're just looking for relationships. It's poor methodology. These are observational data sets where there's a tremendous amount of selection bias in which patients get which treatment. And at the end of the day, these papers are trying to compare two different treatments to tell us which treatment is better. The only way to do that, really, in a reliable way, is a randomized trial. So observational comparisons are hypothesis generating, but they should not change clinical practice. Oftentimes there's no context for what they're trying to study. What is the background? Why are you asking this question? And one of the clearest signs of a poorly written paper is a very, very long discussion, because the discussion really summarizes prior data, and that's relatively easy to write. You can just sort of summarize prior studies. If you have really something interesting that's new, you would focus on that. Instead, discussions that are long tend to focus on prior research. And ultimately, the conclusions are simply not impactful. There's nothing that you can look at in these papers and apply to the bedside to change patient outcomes. I suspect that the horse is already out of the barn here. I don't think we're going to be able to dial this back because of easy access to data. And I'll talk a little bit about AI. I mean, now from taking a data set to generating an abstract or a paper probably takes minutes rather than months. And so you can crank out manuscripts probably 10 at a time, really. And you can kind of pick and choose which one you think is the one to submit. But at the end of the day, there's not a lot of thought that goes into these kinds of science. And I think it's really important for us to avoid that. And let me tell you, at the editorial level, at the journals, we can tell. Where you're not going to fool us with that, we can tell. So again, as you plan your research, think about the question that you want to ask, why you want to ask it, and how best you should ask. Now, I've talked a little bit about research that's impactful. Let's talk about well-written papers. And this is, if there is a grumpy old man aspect to my personality, this is where it really becomes manifest. I think that papers that are poorly written that are submitted are indicators of a certain sloppiness that may evince some sloppiness in the research itself. So that's not necessarily true, but if you submit a paper that has a lot of spelling mistakes, on the editorial level, we kind of wonder, gosh, this is pretty sloppy. Is the science sloppy as well? So I'll give you a few examples, and some of these are facetious and some of these are kind of serious. But this is kind of how you organize a manuscript in general. It's the introduction, the methods, the results, and the discussion, right? So what do we want in the intro? We want this to be very concise. It really shouldn't be more than a couple of paragraphs. Concisely state the background, the unknowns, and the hypothesis, okay? Many papers start out with heart disease is the #1 killer in developed countries. Everybody knows that. Do not put that as your first sentence, okay? Get down to business. What is it that you want to ask? The reader wants to know right away what this paper is about. The other thing that I see a lot is they say, I want to study the relationship between A and B. And in the introduction, they say, several studies have shown that A is related to B. And my first question is, then why are you doing the study? If several studies have already shown it, what's the point of your study? So don't write that. Tell us what's new, what's different, what gap you're trying to address. The methods are incredibly important. And this is the part that a lot of people skip because there's a lot of minutia here, a lot of acronyms about statistical tests. It's not important that you know the statistical tests. What is important, though, is that the reader should be able to follow your logic. If you want to compare two groups in a large registry, tell me how you define those groups. Tell me what variables you compared. Tell me how you dealt with confounding. And then the statistical method should be detailed enough so that the statistician that I work with, if they had your data, they could replicate the exact same experiment. Results, just simply state the results. What we often see in manuscripts are people who try to interpret the results in the results section. So let's say group A had a higher mortality than group B. What you need to state in the results is that the mortality rate in group A was X and the mortality rate in group B was Y. Don't say the mortality rate in group A was X and the mortality rate in group B was Y, probably because of A, B, and C. That goes in the discussion, not in the results. Simply state the results dispassionately. At the end of the day, you did an experiment. These are the results, okay? Don't let your ego, your sense of self-worth get tied up in your experiment. The whole point is hypothesis testing. Most hypotheses don't pan out. That is not a commentary on your own worth. If anything, it tells you that you did the right thing. So don't let yourself get caught up in what the results are. The discussion. Again, long discussions are the surest sign of a bad paper. Summarize the findings. In this analysis, we showed what? Put it in the context of prior work. Prior studies have indicated that there is no relationship between A and B. These papers were limited by the data set that they used, the context in which they were studied. They were 10 years ago. Therefore, we decided to address that gap by using a more contemporary nationwide analysis. And talk about the future directions. What do your results really mean? What do they mean for the future of clinical care? Maybe they mean something for the future of research. Put all that into the penultimate paragraph. The last paragraph should be the limitations. And every analysis, even every randomized trial, has limitations. Be honest about it. Say, look, we had a lot of data we didn't capture in this data set, so we can't tell you how C affected the relationship between A and B. That should be the subject of a future study. And then finally, the conclusion. Be very concise. Tell me what your paper showed, and tell me whether or not your hypothesis was proven or disproven. Now, let's talk a little bit about how you should phrase certain things. Let me see if yeah. So be very concise, okay? Polonius in Hamlet said, brevity is the soul of wit. So the more brief you can make your sentences and the more to the point you can make them, the better off the reader will be. So for example, here's a terrible phrasing. It should be emphasized that these proportions are not the result of significant increases in moderate and severe injuries, but in many instances reflect mildly injured persons not being seen at a hospital. What's a better way to phrase that? these proportions are not the result of significant increases in moderate severe injuries, but reflect mildly injured persons. You saved on words, the message is much more clear, and the reader understands what you're trying to say. Use active voice. This is a very, very common mistake because people don't want to take credit in a funny way. They feel like, gosh, if I write we, or if I write, our group, that'll come off as egotistical. So instead they'll say an analysis of data was performed. Instead say we analyze the data. You save 3 words and 13 characters, right? It's just sending the same message and the reader knows exactly what you're talking about. Let's see. Oh, there we go. Here's another, let me go back one. I don't know if we can go back. Let me just see if I can go back. Melissa, I might need your help to go back a slide. Oh, there we go. Okay, got it. So here's one based on the Action Registry. A population-based study using the Action Registry, Get With the Guidelines, and Center for Medicare and Medical Services was, oh, sorry, there's a delay here and I'm being a little bit impatient, so the slides keep, there we go. Analysis of claims data was conducted. What's better is the investigators conducted a population-based study. Again, active voice, very, very important. This is actually one of my favorite examples of too much verbal diarrhea. This was a US directive during World War II. And this is a direct quote. Such preparations shall be made as will completely obscure all federal buildings and non-federal buildings occupied by the federal government during an air raid for any period of time from visibility by reason of internal or external illumination. I have no idea what this means, but it sounds good, right? Instead, FDR crossed it out and said, tell them that in the buildings they have to keep the work going to put something across the windows. So, again, FDR, great orator, right? He knew that brevity was the soul of wit and to be direct. So instead of trying to get fancy and use flowery language, just get to the point. Beware of compare to and compare with. This is one of the most common errors we see in manuscripts. And a lot of people don't know this. In fact, I didn't know this when I first started writing scientific papers 21 years ago. Actually, gosh, 25 years ago now. Until it was pointed out to me by my mentors at where I trained. Remember that compare to is looking at the similarities between two things. So for example, shall I compare thee to a summer's day? When you're trying to point out differences, it's compare with. So in scientific papers, when we're comparing groups, we're almost always trying to point out differences, right? So compare with is very, very important. Brain tumors are relatively rare compared with more common cancers, not compared to. So again, beware of that particular nuance. Don't use too many prepositions. It is a matter of the greatest possible importance to the health of anyone with a history of a problem with the disease of the heart, blah, blah, blah. Anyone with a history of heart disease should avoid saturated fats, okay? The point is you're not going to impress anyone with long sentences or with multiple prepositions. We much prefer direct communication. The other thing is when you're formatting your paper, and I see a lot of these kinds of errors. The first is create a title page. Okay, when you're about to send a draft to your co-authors, they want to see a title page. The title page should have the title, the author list, their individual affiliations, who the corresponding author is and their contact information, and the word count. Always insert page numbers. And the reason to do that is that some reviewers are very, very specific, and they'll say, on page 5, line number 20, you say this. I disagree with this particular comment because you forgot to cite this study. Always use page numbers. Always double space. This is a little bit of a marketing kind of thing. When I get a paper to review for a journal and I see that it's just jam-packed, already I have a negative view of the paper because I sit there and I say, gosh, this is like hurting my eyes to read this. Readers and reviewers and editors like to see a little bit of white space, right? It makes it easier for them to digest the material. Always double space. Organization and consistency is key. Another common mistake we see is that people forget to pick a number of decimal places. Different values will have different numbers of decimal places. So one will say, the median age was 65.045. And they'll say the average number of stents placed per patient was 1.2. Pick a number. Usually it's 2 decimal places and use that throughout the entire paper. pick an order in how you describe the comparison groups. If you're going to compare A with B, make sure that all the numbers that you have throughout your manuscript, A comes first, because you don't want to confuse the reader. So again, be very, very consistent in how you do that. And then use headings and subheadings, and be generous with this, particularly for complicated analyses. Let's say you're doing an analysis that has multiple subgroups, and all of it's very, very important. Well, the reader wants to be able to follow your logic. So use subheadings so that the reader can understand exactly which subgroup you're talking about, which part of the analysis you're talking about. So those are just some things to keep in mind. Now, in the last few minutes here, I'm going to talk about what we're dealing with at the journal level with respect to artificial intelligence and how it might impact the future of both scientific research, scientific writing, and scientific publishing. I mean, artificial intelligence is already here. I'm sure many of you are using a lot of these large language models like ChatGPT, Claude, Gemini. What's happening on the editorial side is that we're seeing a lot of more submissions. And I'll go through this a little bit later, but many journals allow artificial intelligence or large language models to be used for writing papers. And the reason for that is that there are a lot of non-native English speakers who are doing good science. And it's probably not fair to reject their papers simply because their command of English is not so great. Artificial intelligence solves that problem. Large language modules solve that problem. But you can understand what the downsides are, and I'll go through that. So we're seeing a tremendous number of submissions now because of the easy availability of large language models. And that's obviously leading to a lot of peer reviewer fatigue. As I mentioned, we get 1,200 submissions a year at Circulation Cardiovascular Intervention, which is a relatively modest number of submissions compared with some of the other journals that are more of a general cardiology readership. And it's important for us and all journals to make sure that we cast the net wide when we're sending these papers out for peer review. You know, peer reviewers in medicine do not get paid. It's voluntary. The culture is that because I am publishing and I'm doing scientific work, and other of my peer colleagues have volunteered their time to review my papers, I owe it to science to review their papers. This is not necessarily true in other fields. In the legal world, for example, for law journals, lawyers get paid to peer review. We do not. So going back to the same people over and over and over again to review these papers, you can imagine that there's a lot of fatigue. There are also data-rich manuscripts now. We have so much data in cardiology, imaging data, waveforms, EHR-derived cohorts. It's a lot more complexity of the data structure, and AI can address that by simplifying the generation of results, right? And generative AI is already being used often silently, as I mentioned. The problem is, what's the downside? What's the yin and yang of this? Retractions have hit a record level. The latest data I have is from 2023, over 10,000 retracted papers. Why? Artificial intelligence will hallucinate references. It may hallucinate data. It may not, in fact, be actual data that you're seeing in that paper that's generated from an actual scientific process. There are large-scale failures. Hindawi, which is a publisher, retracted over 8,000 papers in 2023 linked to so-called paper mills. There's actually a cottage industry of paper mills because of the easy availability of large data sets and an audience that is hungry to get papers on their CV or their resume so they can get fellowship spots or residency spots or even jobs. You can pay these paper mills a sizable amount of money oftentimes, and they will add your name to a paper that will ultimately get published somewhere, largely in pay-to-play journals. So you pay money, they'll publish your paper without any peer review, and you can put that on your resume. But ultimately, none of that science is real. Some of it's frankly fraudulent, some of it's poorly done, but many of those papers get retracted. But there is a way that we're trying to fight back. All the major publishers and scientific journals have created something called the STM Integrity Hub, where we can sort of use tools that are available to look for artificial intelligence, look for fraudulent data, as well as sort of report on certain things that are non-trustworthy. But there are some great opportunities for AI. Look, it can accelerate good science, right? I already talked about non-native English authors. It can automate certain aspects. So I do a lot of clinical trial work. Certain aspects of writing protocols is something that's just boilerplate language, and that can be generated really, really quickly. It can review your statistics and say, are you doing it the right way? Is there consistency? What about missing data? Subgroup multiplicity prompts, et cetera. And the great thing now, actually, which is really exciting, is that some large language models like Gemini can actually generate really, really high quality scientific figures. So a lot of journals, including us, we want an abstract, a graphical abstract that kind of summarizes the science in one figure. You can feed your data or your paper into the Gemini, and it'll actually generate a series of images that you can use. So that's really, really helpful. But what's important is that human accountability has to be there. The AI is not listed as an author, but you can say, look, I used AI to write this paper, and that's allowed in many journals, including ours. You do have to disclose it per journal policy. And if you do use AI, please triple check the references. Verify every single citation, because this is happening not only in the scientific world, but in the legal world. There have been legal briefs that have been written by artificial intelligence that have hallucinated precedent-setting trials that simply did not occur, did not exist. So there are challenges. So what can we do? Well, I think that the way we think about AI on the journal side is that we use it for quality control. You know, we're not using it to replace editors. There's still a human element to what we do, but we can use AI to look at novelty, look at scope, to look at duplicate publication, for example. We can use it to discover reviewers that we hadn't previously thought about. You know, we want to cast the net wide. We want a large tent of people who can review. And again, we don't want to go back to the same people over and over again. There are probably people out there with expertise whom I don't know. But using AI and kind of reviewing what their prior publications have been, we can find good reviewers. It can also create structured review templates so we can have consistency across all of the manuscripts. But for research integrity, AI can be used to detect so-called tortured phrases. Tortured phrases are dead giveaways that AI has been used to generate a paper. I can also look at image manipulation. That's so much not an issue in clinical research, or it is, but not as much as it is in basic science, where gels and electrophoresis can be manipulated to create, or even cells and histology slides can be manipulated to create a certain set of results that the investigators want rather than what the actual science shows. And then it can look at peer review fraud signals. I should point out that artificial intelligence large language models are not allowed to be used for peer review. So if you had asked to review a paper for a journal and you want to feed it into ChatGPT to review it, that is not allowed. And the reason is that it breaks the confidentiality of the peer review process. So again, be very, very careful about that. And STM Integrity Hub is a great website. It actually has tools where you can look for plagiarism, you can look for AI, et cetera. This is a great figure from Nature from 2023 showing how many papers and conference abstracts were retracted in over time. You can see in 2013 it was less than 2,000. In 2023 it was 10,000, and that curve is continuing to go up. Number one, because the amount of fraudulent research is going up, but number two, we're getting better at detecting it as well. So again, we have ways of detecting this, and there's a lot of downstream harm. Because remember, science, when it's published, is used to inform guidelines. It is used at the bedside, and at the end of the day, the patients are the ones that are affected. So this really is a very, very dangerous precedent, and this is something that we're continuing to fight against, again, to preserve the safety of the kinds of things that we're doing. The other reason to not use AI in peer review is that this is a great experiment that was done. And what they did was this group of investigators injected covert but deliberate content into manuscripts that could actually manipulate the large language models to give a more positive peer review. You know, they can come up with certain phraseology or syntax that cause the AI models to say, yes, this paper is great, you should take it. So, you know, these are tools. At the end of the day, AI is a tool. And like any other tool, it can be manipulated. So it's another reason not to use AI in peer review and really have a human take a look at these papers that are being submitted to the journals. Here are the policies for the major bodies looking at AI and what role it has for both authorship and reviewers. You know, at the end of the day, you can't list ChatGPT in the author list, but you can disclose it if you used it. And again, you really should not be using AI for peer review because it breaks the confidentiality of the review process. I suspect that this is going to continue to become more consistent across scientific groups as well as publishers. So let me wrap up here. In summary, you know, impactful research papers, it's really about how current research adds to the existing knowledge base. Be careful how you phrase things. You want to make sure that your paper is novel and it addresses prior scientific gaps. Be incredibly meticulous about your writing. If you've looked over your draft twice before you submitted it, look over it 2 more times. You'll be amazed at what you pick up. No spelling errors, good English syntax, good grammar. Avoid that trap of the long discussion. Make your point and summarize how it should impact clinical practice. And artificial intelligence is going to change all of this. We're really witnessing a revolution, not just in the way we do science, but how we publish it, how we review it, and how we disseminate it. So we have to be very careful as this train is leaving the station and accelerating. As a community, we have to be careful and we make sure that we use it the way we should. So again, caution is warranted here. So that's sort of what we look for. For those of you who are interested in submitting proposals, here's the AHA project timeline. Once a project is accepted and you've received the data, the AHA really expects a first draft of the manuscript that your co-authors have approved the first draft within 3 months. The first draft within 3 months, the co-authors have reviewed it, and the final draft within 6 months. So that's a pretty good period of time from the time you get the data to the time that you actually submit that paper to the AHA. There is a scientific review that's done by the AHA, similar to the American College of Cardiology's registries. It gets reviewed by the AHA for scientific merit, making sure that all the numbers pan out and the phraseology is correct for how you've couched those results. Once the AHA science review is completed and it's approved, you really need to submit that to the journal within 30 days. And really at that point, there's no reason not to. I mean, you can revise based on what the science review has shown, and that revision usually is pretty cursory unless there are major issues with the paper, but you want to submit that within 30 days. And then the overall at 12 months really is is when the project ends and when the paper should be published. And this has been a very successful model for all the Get With The Guidelines registry papers. I think there have been really some very impactful research that's come out of Get With The Guidelines as it relates to both heart failure as well as coronary disease. And STEMI, for example, is sort of the one that comes to my mind immediately, is how do we deal with door-to-balloon times and inpatients and transfer in, transfer out. So these are, I think these registries are really ripe for great science. The next deadline for proposals is August 15th. So get your research groups together, start brainstorming, take a look at the data collection forums, think about what are interesting questions that could impact the way you practice, or maybe you've noticed something in your own patients that you say, gee, I wonder how often that happens. These registries are great for looking at that. Looking at patterns and practice patterns and outcomes they're really ideally suited to that. And so hopefully we'll get some great research proposals from all of you, and we look forward to entertaining many of them that might have an interventional bent in circ interventions. So thanks again for the opportunity to present. I want to thank all of you for dialing in, and I'm happy to take any questions or comments if people have any.
Thank you so much, Dr. Rao, for that wonderful and incredibly informative presentation. We currently don't have questions, but if anyone does have any, please feel free to put those into the questions pane now. Give that a few seconds and see. That was really incredible. Thank you so much for your time. It looks like.
Yeah, thanks.
It looks like that'll be it. Thank you so much for everyone for joining us today. A reminder that you will receive an email with the recording in about 2 hours. Have a wonderful day.
Great.
Enjoy the rest of your week. Bye-bye.
Bye-bye.